Hello everyone. Welcome to the lecture series on machine learning. Today's topic is linear regression. So let's get started. So first of all, let's understand what linear regression is. So, linear regression is actually a machine learning technique. Just like as a human being, we use different ways to learn different things. For example, if we want to learn a sports, the way we learn it is different, right? It is related to study. If it is related to studying, then method is different. Learning method is different. If we want to learn a musical instrument, then the technique is different. So basically, we use different techniques to learn different things. In the same way, a machine learning model can use different techniques for different tasks, and linear regression is one such machine learning technique. So, what does this technique actually do? Basically, this technique is used to predict a number. Now, what number we predict and how we predict it, we will understand step by step as we move ahead in this video. Let's also understand one or two technical terms that we are going to use in this video. Basically, linear regression finds a relationship between two things. We call it variables. And now, what are these two things and what exactly is their relationship? We will understand that through various examples. For now, just remember that linear regression finds a relationship between two variables, two things. There is one more technical term related to linear regression, and that is the straight line. Linear regression represents the relationship between two variables through a straight line. This line is called the regression line, and it is also called the best fit line. Now, how does this line help us predict a number? What exactly does this relationship mean? And what exactly does the straight line mean? We will understand all of this slowly, step by step. Let's understand these terms with this example. Suppose we want to predict the marks of student. So what would we do, right? We may ask that how many hours does this student study, right? So based on how many hours the student studies, we may predict how many marks the student could get. For example, we may commonly hear something like Sharma uncle's son got 80% because he studies for 8 hours, right? So basically we have some past data. We may have information about how many hours different students studied and how many marks they got. So now what does machine learning do? Machine learning also works with this data points, and tries to find a straight line. As you can see here in a graph, study hours versus marks. And here we have, for example, for 1 hour there are 20 marks, for 2 hours there are 40 marks, and like that. And this is called a line, red line. This is a regression line. So machine learning also works this data points and tries to find a straight line. This straight line represents the relationship between the two variables, and here these two variables are study hours and marks. So here both the variable can change, right? Study hours can increase or decrease, and marks can also increase and decrease, right? So the relationship between these two variables can be represented using a straight line. This is basically how linear regression works. So as we move ahead in this video, all these concepts will become clearer. So don't worry if you think that this is little bit complicated, so don't worry about that. So this is about the very basics of linear regression. Just like we use our past experience and understand that if a student studies for more hours, they may get better marks, right? Linear regression also does something similar. We give the model training data, and from the data it tries to find a pattern. So now what is pattern? For example, more study hours means more marks, right? So how did we understand that if a student studies for 8 hours they may get around 80%? Of course. And if a student studies for fewer hours, the marks may generally lower because of we have identified that pattern, right? In the same way, how we can say that more work experience means more salary, higher salary, right? Suppose rainfall, then more rainfall means more crop production. So all these predictions if we make, it means that we have experience, we have the past data, right? So, in simple technical words, we can say that linear regression is finding a pattern in data using a straight line to predict a number. And now let's understand linear regression step by step in a little more detail. Let's take our study hours and marks example in a little more detail. Here we have data data where we have the study hours and how many hours a student studies, and against that we have the marks out of 100, right? So for example, our data may show if a student studies for 1 hour, the student gets 25 marks, which we can actually see here. If the student studies for 2 hours, the student gets 38 marks, and similarly, right? So we have many other data points as well. So now if we plot this data on a graph, we can see the relationship between study hours and marks over here. So we can see that the data shows an increasing trend here, right? From this red line we can see this. So this red line is called the best fit line. This red line is called best fit straight line, and it is also called the regression line. So basically this line shows the overall pattern in the data, and it helps us understand how study hours and marks are related to each other. And now, when we give this data to the machine learning model, the model gets trained, right? And after training, we test the model. Suppose we ask the model, if a student studies for 7 hours, approximately how many marks could the student get? The trained linear regression model uses the relationship it learned from the training data and the regression line to estimate the answer. So, for this simple example, suppose it predicts approximately 100 marks, right? So, when we give 7 hours as the input, the model predicts approximately 100 marks, and this is how linear regression actually works. But we should keep one thing in mind always: there is no guarantee that this prediction will always be correct, right? Because marks are very subjective thing. So marks and the study hours, when we say student to student, it varies, right? Mm. So it is not only about the number of hours of studies. We also have to consider how focused the student is, whether the student is genuinely studying, how effectively the student is studying, and many other factors. So the actual value may be different from the predicted value, and that is why we call it a prediction, right? So when we say prediction, it means the estimated value may differ from the actual value. So we should always keep this in mind. So this is all about study hours and marks example. Now let's take another example, experience and salary. Suppose we want to understand how much salary a person get based on their years of experience, and we will see exactly the same pattern here as we saw in the study hours and marks example. So here we have data that we can use to train the machine learning model. For example, if a person has 1 year of experience, the salary may be around 3 lakhs per year. Then, if the person has 2 years of experience, there may be another corresponding salary. And similarly, we have data for different years of experience. From this data, a graph can be created. So through this graph, we can find a straight line, that is the best fit straight line, right? And based on this line and the relationship learned from the data, we can make a future prediction. So suppose we ask, if a person has 7 years of experience, what could their salary be? So for this simple example, suppose the model predicts approximately 9 lakh rupees per year. So the model has predicted a salary of approximately 9 lakhs rupees. Again, this is only a prediction, so there is no fixed rule that says that 7 years of experience means exactly 9 lakh salary, 9 lakh rupees salary per year, right? Salary can depend on many factors. So whenever a machine learning technique makes a prediction, we should always remember that it is an estimated value and not a fixed rule, right? So this is all about experience and salary example. In the same way, let's take another example. Suppose we want to predict a crop production based on rainfall. So here, rainfall. So here we have data showing how much rainfall occurred and how much crop production was obtained. So again, we can plot this data on a graph, and from the data, linear regression finds the overall pattern and represents that relationship using a regression line. And now suppose we give a new input like 650 um, millimeters of rainfall. Then based on the learned relationship, suppose the model predicts that the crop production could be around 4.2 tons. So again, this is a prediction, it is not a fixed value. So this is all about rainfall and crop production example. So after seeing these examples, now we understand the basic idea of linear regression, right? Now we know that the linear regression finds a relationship between two variables and represents the relationship using a straight line. Now let's see how this red line, which is our regression line, actually works. Today we will also look at some of the mathematics behind linear regression, and we will understand the technical part in a very simple way. So the line that linear regression draws is called a best fit line. And now, why is it called the best fit line? Because this line is chosen in such a way that it represents the data as well as possible, right? So the most important job of this line is to reduce the prediction error between the actual values and the values predicted by the line. For example, For example, suppose a student studies for 1 hour and the model predicts 90%. For example, that would be a very large prediction error, right? So if the actual marks were much lower. So similarly, suppose someone has 15 years of experience and model predicts a salary of only 10,000 rupees. So that would also be a very large prediction error. So the model tries to find a line where these prediction errors are as small as possible. So technically, in ordinary linear regression, the best fit line is found by minimizing the sum of these squared errors. So overall, this red line, which is a regression line, best fit line, represents the overall pattern in the data. It helps us understand the relationship between the variables. It also helps us understand the direction and the slope of the relationship. And when new data comes, the learned relationship helps us estimate the output. Another important thing is that by looking at the line, we can understand the relationship in a simple visual way. So it becomes easier to understand the data. And this concept of regression line is also an important foundation for understanding many advanced machine learning concepts. So this is the basic idea of the um, linear regression. Now if you look at the graph, you can see a vertical gap over here. This is a vertical gap. So what does this vertical gap represents? This gap actually represents the error. This gap, so it represents the error. More technically, it is called the residual. This is the correct word, technical word. It shows the difference between the actual value and the predicted value, right? So on the regression line, so the line is chosen in such a way that these errors are minimized. In ordinary linear regression, the goal is to minimize the sum of squared residual. So basically, the line tries to fit the data as well as possible. So you can say that the regression line is the best straight line that captures the trend in the data and helps us predict a future or a new value. So you can remember one simple thing, that the regression line is actually the heart of linear regression. So this is all about this regression line. So we have seen what linear regression is. We have also seen different examples. We saw the red line, which is regression line, and we understood its use. Now let's understand a little bit of the mathematics behind it. Exactly how does linear regression predicts a number? What kind of calculation does it perform? We will understand all of this in very simple words. So linear regression is not just about drawing a line. Actually, there is a mathematics and statistics behind how that line is actually created. So let's understand a little bit about that. Linear regression basically follow an equation. Mainly entire artificial intelligence, all the machine learning things, everything is actually a maths and stats, nothing else. So okay, linear regression basically follows an equation, and the equation says is y is equal to mx plus c. Now let's understand what each variable means. Here y means the predicted value. This y, it's a predicted value. Then it is actually our final output. This y is actually our final output. Then we have x means the input variable or a feature. For example, if y is the marks we want to predict for a student, then x could be the number of study hours, right? So then we have m, small m, which represents the slope. Slope means how much y changes when x changes by 1 unit. That is the meaning of m. And finally, C is the intercept. The intercept means the value of y when x is equal to 0. So these are the four important things in our equation: y, x, m, and c. We will understand this equation step by step. Now let's understand this equation using this graph. Here we have an x versus y graph. The x-axis represents x and y-axis represents y. So now this point where the regression line crosses y and x is our actually intercept. This, right? Intercept C. This is actually intersection, and this is called the intercept C. This is intersection and this is intercept. So what does the intercept means? It means the value of y, because this is yx. So the value of y when x is 0. So this is the meaning of intercept. So c is the value of y when x is equal to 0. Then we have m, which is the slope. This is m, which is the slope. So the slope tells us how steep the line is and in which direction the line is moving basically. So m shows the steepness and direction of the line, and c tells us where the regression line cross the y-axis, right? So, or in other terms, we can say from where it starts, its origin actually. So m is our slope and c is our intercept. So this mathematical part basically helps us understand several things. For first, how the best fit line is found. Then second, how the slope and intercept are calculated. Third, how the prediction is made. Fourth, how we measure the error in our prediction. And finally, how statistics helps us evaluate the model. So there is mathematics and statistics behind the linear regression. So this is all about the equation behind the linear regression. Now let's take one simple example and actually calculate predicted value. We already understood the equation, right? Y is equal to mx plus c. Now let's see how we can use this equation with an example. For example, we will take the share market example. So our goal is to predict the stock price based on the trading volume. So this is only a simple illustration example to understand how linear regression calculates and predict value. So, step 1 is our equation. A linear regression equation is y is equal to mx plus c. We know, but let's revise it. So, here y is the predicted stock price, because we have taken the uh, share market example. So, here y is predicted stock price. X is the trading volume measured in lakhs shares, M is the slope, and C is the intercept. So our complete equation is y is equal to mx plus c. Now we have the equation. Now let's look at our data. Now step 2 is our sample data. Here we have trading volume and stock price. So trading volume means x and stock price is my y. Here we have this data. For example, as you can see on the screen, like for let's say 10 lakh shares for 100 rupees, and 20 lakh shares, stock prices 120 rupees, and like that. So this is our sample data. Now linear regression looks at this data and finds the relationship between trading volume and the stock price. For this simple example, the data follows a straight line relationship. um, Now we need to find two important values, that is m and c, right? M and c. M which is the slope and c which is intercept. So let's calculate it. First let's calculate. You can use paper pen for this thing. First let's calculate m, which is the slope. Slope tells us how much y changes when x changes. So let's take 2 points from our data. X is let's say 10 and y is 100. So you just have to put these values in the equation, right? So when x is 10, y is 100, and when x is 20, your y is 120. So the change in y, you can see the change in y, you can see is 120 minus 100, which is 20, right? 120 minus 100, which is 20. And the change in x is 20 minus 10, 20 minus 10, which is 10. So m is equal to change in y divided by change in x. So keep in mind, m is equal to change in y divided by change in x. So therefore m is equal to 20 divided by 10. So the m is equal to 2. Please use paper pen and do this calculation by your own. It will help you to understand actually. So now we got slope value m is equal to 2. This means that in this simple example, for every increase of 1 lakh shares in trading volume, the predicted stock price increases by 2 rupees. That is the simple meaning. Now we need to calculate c, which is the intercept. We already know our equation, y is equal to mx plus c. We know that m is 2. So we have value for x and m both, right? So we can and for y as well, because we are using this example. So from that we can calculate c. So let's take the first data point, this one. X is equal to 10 and y is equal to 100. Now we put these values into the equation. So 100, this 100 means 100 is equal to 2 into 10 plus c. So c value we will calculate, and therefore finally we will get c is equal to 80 by doing this simple calculation. So finally our intercept is 80. Now we have both the values, m is equal to 2 and c is equal to 80. So our final regression equation becomes y is equal to 2x plus 80. And finally we got this, right? Because now we have value of m and c with us. So we just need to put the value of x and we will get the prediction, which is our y. Now comes step 3, predicting a new value. So suppose today's trading volume is, suppose let's say 35 lakh share, right? So x is equal to 35, we want to predict the stock price. So simply in this equation, y is equal to 2x plus 80, we put the value 35 and finally we got 150. That is a predicted stock price for 35 lakh volume is 150 rupees. So when we give 35 lakh share as the new input, our linear regression model predicts stock price of approximately 150, right? We need to keep in mind this is approximately 150. Now let's understand the same thing visually. Here, as you can see in this graph, you can see in this graph that x-axis represents trading volume and y-axis represents stock price, right? That you can see over here. The red line is our regression line, now we know this. And this line represents the relationship that the model has learned from the data, right? Relationship between the trading volume and the stock price. So now when we give a new input of 35 lakh shares, we can use this learned relationship to estimate the corresponding stock price. And in our example, the predicted value is 150. So somewhere here we can plot it. So the equation helps us calculate the prediction and the graph helps us understand the prediction visually, right? So now one important thing we should always remember in our mind, uh, that this 150 rupees is a prediction, right? So it is not a fixed rule or a guaranteed stock price. This is only a simple example to understand how linear regression works. In a real stock market, many different factors can affect the stock price, right? And that we know. So we should always remember that the machine learning prediction is an estimated value based on the patterns learned from the available data. So, what did we learn from this complete example? We started with some data, then we found the relationship between the input and output. We calculated the slope m and intercept c. Then, using these values, we created our linear regression equation and we got y is equal to 2x plus 80. After that, we gave a new input. 35 lakh share of trading volume, and using the equation we calculate predicted value, that is 150 rupees. So this is how linear regression uses mathematics to learn from data and make predictions for new values. So, in short, linear regression is not just about drawing a line, there is mathematics and statistics behind how that line is created and how the final prediction is calculated. So, today we understood the regression line, the best fit line, the equation y is equal to mx plus c, the meaning of slope and intercept, and finally now how we can use the equation to calculate a predicted value, that also we learn. And this is the basic mathematical idea behind the linear regression. So that's it for today's video. See you in the next video. Till then, bye bye. Take care.